How y'all folks doing this fine day? This is the cable company, and this is my NASA. This is an artist's conception of the. This is the building for the spaceship Atlantis, Mercury. I want to dedicate this to all the Rocketeers out there. Bob and Tony Revels, they was in the Apollo mission. I want to thank them for their contributing to that mission. Also, I want to dedicate this to my girl, Lisa. This is her. She was an organ donor and didn't want to be. Okay, that's what Lisa's grandbaby law. That's what this is all about. I'm showing you this. Here's a fact sheet. Now, I talk about the facts. I have fact sheets and stuff, and of course, there you go. This is the Atlas Mercury. General Dynamics, Astronomics. Atlas Mercury. Project Mercury is the United States' initial manned satellite program under the direction of the National Aeronautics and Space Administration, NASA. The launch vehicle is built by General Dynamics Astronomics, a division of General Dynamics Corporation, and the spacecraft is built by McDonnell Aircraft Corporation. Project Management. NASA is responsible for overall management and direction of the project. In 1958, the Space Task Group was organized to develop a manned spacecraft to orbit the Earth under Robert R. Gilruth, the project manager. The group was recognized in 1961 as the Manned Spacecraft Center. The center is responsible not only for the technical management and contract administration of Project Mercury, but for future manned space programs as well. Project objective: to put a manned spacecraft into orbital flight around the Earth. 2. To recover successfully the spacecraft and its occupant. 3. To investigate the capabilities of man in this new environment. In November of 1961, a chimpanzee was rocketed twice around the Earth in a crucial prelude to the first manned orbital flight. A General Dynamics Astronautics Atlas will place the manned spacecraft into orbit. A nearly circular orbit will be established at an altitude of roughly 100 to 150 miles to permit a 24-hour spacecraft lifetime before it is returned to Earth. 3. Descent from orbit will be initiated by retro rockets on the spacecraft. 4. Parachutes will lower the vehicle after it has entered the atmosphere and been slowed by aerodynamic drag. 5. Recovery will be made on land or water. The launch vehicle. The United States' most powerful operational launch vehicle for space missions, the Air Force Atlas, was selected by NASA to lift the first U.S. manned spacecraft into orbit. Series D Atlases are used as Project Mercury launch vehicles. They undergo minor modification for the space missions at the San Diego plant of Astronomics. The modification consists principally of alternation in guidance and autopilot system. Astronautics has also designed the abort sensing and inflammation system to detect any malfunction during launch and trigger the automatic escape mechanism. The basic vehicle is 75 feet long, 10 foot in diameter, and developing takeoff thrust of 360,000 pounds. Is unchanged. The overall Atlas Mercury combination is 95 feet long. The manned spacecraft fitted atop the Atlas with an adapter structure is manufactured by McDonnell Aircraft Corporation. All launchings are conducted from modified Atlas complexes at the Air Force Missile Test Center, Cape Canaveral, Florida. The first ballistic test shot, Big Joe, which used an Atlas and an unmanned, heavily instrumented pre-production spacecraft, was made from AMR on 9 September 1959. The spacecraft was recovered from the Atlantic, and NASA reported the test yielded valuable re-entry and recovery data. On the 21st February 1961, the Atlas Mercury vehicle carried a full-scale production model spacecraft to peak altitude of 115 miles. In re-entry, the spacecraft was subjected to 3 times the normal Mercury orbital re-entry air loads. Mercury pre-launch checkout operation and launch countdowns are conducted from the Atlas blockhouse by astronomics technicians. Working with representatives of NASA, the Air Force, and associate contractors, the normal research and development Atlas countdown is lengthened by 30 minutes to include capsule checkout operations. This is the manned spacecraft system vehicle. The manned spacecraft has high aerodynamic drag and is statistically stable. The spacecraft of the non-lifting type is designed to withstand combination of acceleration, heat loads, and aerodynamic forces which occurred during launch and re-entry. It has a blunt leading face covered with a heat shield. Life support system. A couch in the spacecraft supports the astronauts during acceleration and re-entry acceleration. Pressure, temperature, and composition of the atmosphere in the spacecraft is maintained with human limits. Food and water are provided. Attitude control system. The spacecraft has a closed-loop control system which maintains the vehicle in orbital attitude and establishes the angle for retro-rocket firing, re-entry, or abort maneuver. A renegade system. The system provides sufficient impulse for re-entry in less than one-half an orbit after the retro rockets are fired. These rockets are fired either by a command link from the ground control or by the astronaut. The impact area is computed from the spacecraft's point of re-entry into the atmosphere. Recovery system. As the spacecraft re-enters the atmosphere and slows to approximately the speed of sound, a drogue parachute opens to stabilize the vehicle. At this time, radar is released to pinpoint the spacecraft's location. When the velocity of the spacecraft decreases, a landing parachute opens high enough for a safe landing on the land or water. The spacecraft is very buoyant and stable in water. After landing, recovery aids include tracking beacons, a high-intensity flashing light system, a two-way voice radio, solar bombs, and dive markers. Escape system. The primary escape system is the Abort Sensing and Implementation System, ASIS, designed by General Dynamics Astronautics. ASIS is a highly reliable system designed to guarantee the safety of the Mercury astronauts during the powered phase of flight. At any time a malfunction occurs which would alter the pre-designed flight plan, the ASIS triggers the automatic escape mechanism made by McDonnell Aircraft Corporation. The spacecraft is separated from the vehicle by rockets and parachutes back to the Earth. After the spacecraft is in orbit, however, the astronaut can re-enter the atmosphere at any time by activating retro rockets. Other safety control features are also incorporated. Guidance and tracking. Ground-based and vehicle-borne equipment guide the spacecraft into orbit. Ground and spacecraft equipment determine the spacecraft descent and predict the impact area. Communication. The two-way communication between the astronaut and ground station is maintained during flight. Equipment includes a two-way voice radio, a receiver for commands from the ground station, and a radio tracking beacon. This communication equipment is supplemented by the special recovery aids. Instrumentation. Medical instrumentation is provided to evaluate the astronaut's reaction to flight. Instrument measures and monitors the internal and external spacecraft environment and makes scientific observations. Data is recorded in flight and telemetered to ground recorders. Test program. As in the case of the new research aircraft, orbital flight of a manned spacecraft takes place only after a build-up of vehicle capabilities and scientific data. Project Mercury includes ground testing, development, and qualification flight testing and astronaut testing. Training. A highly successful suborbital flight was conducted before May 1961 using a Mercury Redstone launch vehicle. On the 29th of November 1961, a chimpanzee named Enos was boosted aloft by the Atlas Mercury and orbited twice around the Earth before being successfully recovered. Shortly afterward, astronaut John H. Glenn, Jr., a Marine Lieutenant Colonel, was selected by NASA to make America's first manned orbital trip. The flight is expected in early 1962. All right, there's your fact sheet about one. I told you, I promised you I'd read you some more of the. I'll show you some more of our ships. Well, let's see. Well, we doing on time? We doing all right on time? Okay. Let's see here. Well, that might take a little time there. We'll do that one on the next one. I'll try to do that one on the next one. Here, look at this one. Here's your picture. This is construction. This one here is an area view of the LOCMILA. This is an area view. This is a NASA photo. But there's your good picture there. That's a real picture. And I got some, let's see what this one here is right here. I guess I'll put that back in here later. I'm going to try to get this one out. Let's see if I can get this one out here. Okay. And this one right here. Well, this is basically, this is the same one. It's just a drawing of it. And, but anyway, there you go. I'm glad you got to come and see me. Please come back and see me some more. You can write to me if you want to. Mitchell Aaron No Sr., 301 Harbert Valley Road, Toccoa, Georgia, 30577. Write to me today. Tell me what's on your mind, and I'll tell you what's on mine. Come back and see me, okay? Bye-bye.